Anyhow, gas laws. So a question that I would ask you to ponder as well is, are gases and fluids the same? Again, I don't know. Some of these things, is there a right or a wrong answer? I don't know. But these are things that, again, I want you, or at least I'm hoping that you will take some time to think about. All right, so let's begin. Yes. So I think we used as our official definition of fluids is anything that takes the shape of whatever it's in, and that seems like a very intuitive, natural definition of fluid. But by that argument, or by that definition, you might say, isn't a gas the same thing? So what I'm asking, the first thing is that you should do, I guess, outside of what we're going to talk about in 30 seconds, is what is your definition of a gas? So it goes back to what I was just saying about a minute ago. Like, if I asked you to define the word area, what would your definition be? If I asked you to define the word fluid, I know we gave our sort of hand-wavy definition, but what would your definition be? If you're explaining this to a kindergartner or a 5-year-old child, what is a gas? So these are the kind of things that, you know, I hope that you spend some time to think about. All right, anyhow. Oh my God, someone's having a party. Who's partying in the house? It's over.
I was accused and derided, as some of you guys know, because of my position on sexual confusion in the African American community.
All right, so here's what we're gonna do. I got something. What is happening? What is it?
Okay, of that community. And so I think it's important that I clarify my perspective on Black homosexuality and lesbianism so that we're all crystal clear on where I stand. Yes, it is true, I do not support it. Yes, it is true, I do not condone it. But it is absolutely false if anyone says that Dr. Umar Johnson hates any of our brothers and sisters.
We're learning. This is good. We're learning something. What are we learning about? Are we listening to the news? What is happening? I was just getting into that. All right, so we're going to consider 4 things with gases. 4 things that are going to be important. So, and again, I haven't defined what a gas is, and I want you to think about that before we even attempt to make a definition. But we all have an idea of what a gas is. So let's use our intuition for now. And we're going to talk about sort of 4 things that are going to help us describe gases. Most important, I shouldn't say most importantly, that's bad, but the first thing we're going to do is pressure, or the first thing we're going to mention. Temperature, volume, and something we haven't used yet, but I'm confident that you guys know what a mole is from maybe your chemistry class, Dr. Fujito. No, yeah. So you guys are like, yes, of course I know what a mole is. But if you don't, you Google it. And we think about moles as, I don't know how you want to think about them, but a way of characterizing gas. So if you're sitting there and like, I don't know what a mole is, well, just pretend that a mole is one way that we're going to use to characterize gases. So that's your, you know, until you go to the Google machine or your chemistry book or whatever, that's what a mole is. So also I would encourage you to shoot out my email if you're like, I don't know what a mole is. All right, so basically, here's what happened. If we look at a historical perspective on these things, you have people who studied gases, and uh, what they realized, years ago, as far back as a few hundred years, is that these were the four things that were the, I guess, the most suitable or the best way to characterize how gases behave. And then they did experiments, and because of their experiments, they noticed certain behavior. Like, as you guys know, when the temperature changes, you got to put air in your car tires. Or if you have a basketball sitting in your garage, when the temperature changes, it loses, air, as you might say, or it loses pressure. And so we want to think about these things from a more scientific perspective. And luckily, people did this years ago, and then they have laws named after them because of this. So, I always find it interesting, at least for me. And again, I don't know that you guys, or I guess I shouldn't even expect you to be as curious about all this as maybe I am or other people are. But when I learned about these things, long time ago, I was curious, like, why would they study it in this way? Why would they study in that way? Or who cares about how pressure and temperature are related? But you got to remember, is like the scientist is the physicist or whatever. I mean, a chemist, biologist, whatever you are. But I guess since we're in a physics class, we should think from that perspective. I mean, your job is to try to explain why the tire needs air, or why you have to pump up a basketball, or what happens to a balloon if it's sitting in your, in your house for 3 weeks. Why does it, for the first week, go up to the ceiling if it has certain, chemicals in it, or gases, I should say, chemicals. And why does it fall to the ground after a few weeks? Why do these things happen? And not just why, but how do we characterize it? How do we quantify how long it's going to take for something to happen? And so, like, someone like myself who is curious about these things, I find it interesting. Maybe you guys are just, thinking, well, this is just sort of what I have to do because they tell me I have to do it for my degree. I don't know. Like, I think about, like, we you probably know these words: Boyle's law, Charles' law, all that stuff, and the ideal gas law. And you might think, well, like, I'm curious, like, what was Boyle thinking, or Charles? Are they just going to sit around and, like, inflate things or pump air into stuff and watch them? And it's actually funny to give you an anecdote. When I was in 8th grade, no, I'm sorry, 10th grade, at the science fair, that was my science fair project. I did some gas nonsense because I was curious, why. I don't remember what I learned, but at least at that time, it allowed me sort of, yeah, I don't know, the curiosity of why do these things happen? Why, if I take a certain balloon and I inhale whatever gas is inside of it, does my voice sound funny? Or, why is it that if I heat something, it behaves differently? So it's not just why does that happen, but how do we quantify exactly how it's going to happen, which at least to me is a fascinating thing. All right, so so we have four things that sort of characterize gas, and a bunch of people years ago who were interested in this, a bunch of nerds like myself, studied it, and they figured out how these things interact. And the first one you usually talk about is Boyle's law. So how are these four things related? I shouldn't say legend. Who knows? Boyle could have been a jerk. Who knows? I don't know enough about the personal life of Boyle. So what Boyle did is he studied if you have a gas. And again, what's interesting, and I know I'm repeating myself and I sound like a broken record, but we never really defined gas yet, and that's on purpose. So it's not like it's a cop out on my end. I want you to think of these things without having some specific physical definition of a gas. I want you to think about what your definition is, as we said earlier. So anyhow, what Boyle did is he studied volume versus pressure. And again, I find this interesting. So we teach these gas laws. And as a student myself, I used to think, well, what do you mean pressure of a gas? What does that even mean? And so hopefully you're having the same question that I had, 20 some years ago when I learned these things in a physics class. Like, what does it mean for gas to have a pressure? Again, I'm assuming I keep using the example of a tire, like a car or a basketball or anything, but what do we mean by pressure? So I think it's good. I think it's a good learning tool for you to think about these things. It sounds stupid. We use the word pressure all the time. Well, I shouldn't say all the time. Maybe you don't use it all the time, but you definitely have to put air in your tires. You definitely, at least, now your car tells you, I guess, when you need air in your tires. And you might say, well, I'm going to put 32 PSI in, or pounds per square inch. But what does that really mean? So again, I think it's a super useful thing for you to question these words that you kind of use a lot, but you necessarily, if someone offered you $1,000 for a definition, you might not be able to define it. So I think that's a good thing to do, is at least think about it that way. All right. So, all right, what is Boyle's law, so to speak, or what did Boyle figure out for the people? Is so in English, what we find is they're inversely, I guess, is related. So in English, we say they're inversely related. That means if one goes up, one goes down, and vice versa. But what does that mean more specifically in physics or math language? It means the following. So this is what we all hate, the math part. So let's suppose we have a gas. And we'll be sort of vague again, that starts with a specific volume and pressure. So let's give them a name. So we'll be real cute and call the specific volume V1, and we'll call the specific pressure P1. So again, we're using these subscripts here. That's what we do in math. That's what we do in physics. It's sort of the way. So you have an initial pressure, you have an initial volume. And so again, I'll be very vague. So if the pressure and volume change, to new values, getting sloppy here. What is happening? So we'll call the new ones P sub 2 and V sub 2. Here's what you have. You have the initial pressure times the initial volume must be equal to the new pressure and the new volume. And so the way you need to think about this is as follows. You're not making this up as here's what we want to happen. What you have is you go to an experiment, whatever it is. You take a gas, you take a basketball, you take a car tire. And what you do is you fix everything in its environment. You fix the temperature outside, you fix everything. Or at least you control the environment. And what you ask yourself is, if I take this gas and I move it to a different size thing, I change its volume. And if you fix everything else in the environment, except perhaps if you can do this, the pressure and the volume, then these things must obey this. And what do we mean must obey? Well, what we learn is we didn't say this rule, we didn't say this algebraic sort of equation from the get-go. What happens is people do experiments and they record their results. And what we realize is this is what happens in these experiments. So if you get the pressure and the volume if you allow that to change and you allow everything else, whatever everything else is, you have this ideal situation where you're saying, I'm going to hold my temperature fixed and moles, whatever they are for that matter. And if I just allow the pressure and I just allow the volume to change, here's what I have. So it's weird. You can think of it solely as some mathematical rule or some physical law, but you can also say, oh, okay. So what we have is we notice this through experiments, just like we talked about before. You think about an experiment. Hey, if I take an object and I hold it here and I drop it, I know what happens. It goes to the ground. And so then maybe I'm curious and I say, okay, how long does it take to get to the ground? Can I do this experiments with different objects and record data on how long it takes things to get to the ground? Just like I can go every day and I can take a basketball and I can put it in a room with a fixed temperature, and then I can say, okay, I'm going to pump air into this to change the volume, whatever air is. How does that change the pressure, or what does that even mean? So these are the kinds of things, I would hope that you think about, other than just memorizing some silly law like this one, which we call Boyle's law, or Charles's law, or what we're going to talk about soon enough, which is called the ideal gas law. Instead of just memorizing these things or think about them. Anyhow, does anybody have a question? Just pretend. I'll nod your heads like, yes, of course. Oh, Grady, this is so exciting. I couldn't wait this morning. I woke up and then you were 5 minutes late for our Zoom class. And I was so sad because I couldn't wait to hear about the gas laws. Anyhow, so this is what we call Boyle's law. All right, so what I find fascinating too is, like, I made this joke, I think last week. I'd imagine you guys are all familiar with at least the term pressure, right? I mean, you've probably used pressures and at least read a gauge before in your careers. Just like we laughed last week when I'm talking about, I'm sure you guys have taken blood, or you've put an IV in, or you've given shots. I'm highly doubt you ever thought, how fast is this fluid moving through my syringe? But now you know how to do that. So now when you're reading gauges, you can think about Boyle's law and Charles' law, and you can say, hey, this is so exciting. You can even tell a patient, like how you have this dumb physics professor who thinks this stuff is fun. I don't know. you know how there's like that little whiteboard in hospital rooms, like today, this is your nurse, here's the doctor. And you have that stuff. You guys can like do little physics problems on there. It'd be so fun. Here's how fast your medicine's coming. Your morphine drip is moving at this or that. Okay. Anybody have any curious questions about Boyle's Law? No? It's a beautiful Monday. You should have questions. You guys don't talk enough. I feel like you guys should just randomly say something or program your computer, or so, like someone had their TV in the background on before. That was nice. We had like there's some liveliness happening. All right, so nothing, no one. Damn. No more keyboard, Mr. Hershey. You know, it's not keyboard.
I can open the window. You can listen to some lawnmowers.
Listen to what?
Lawnmowers.
There you go. I like the sound of a lawnmower in the morning. I have one going on behind me as well. I have a neighbor. He literally cuts his grass every other day. I don't understand it. It just must be something like, it makes me think like, wonder what he is thinking about his like life, his wife and his kids. He cuts the grass when it's just unnecessary. So it gets me my brain wondering. Anyhow, that was a nice little detour. Couple things, actually, I should, before we move on to something, and we're going to do an example. So I had someone ask me this question, I want to say 2 or 3 years ago, and I thought it was a good question because I used to have the same thoughts to myself. Like, someone said, why study these things when, so, okay, we said there's 4 things that are important. I said there's this pressure, volume, temperature, and the number of moles. And someone said, why would you study it with pretending the other stuff's not changing? Because that doesn't happen in real life. And I said, absolutely. I said, I agree with you. Like, we're going to talk about what's called the ideal gas law, which only pertains to ideal gases. And we'll explain what that means soon enough. But the fact of the matter is, if you really want to quantify and understand how things happen in the real world, as we call it, what you have to do is you have to simplify things and understand how things work controlled. So if you can control your environment, if you can keep temperature fixed, and if you can keep the number of moles, whatever that means, fixed, then what we recognize, if those things are fixed in a controlled environment, then pressure and volume behave a certain way. And of course, your argument would be, as mine was, and how, as the question was a couple years, well, things aren't fixed in the real world. And I agree, but the point is, if you want to learn anything, you have to simplify things. And so one of the things we do in science is we study the simplified cases. And if we can study the simplified controlled cases and we can understand them, then we might not be able to apply these specific sort of outcomes or say exactly how a real gas is going to behave, but at least we have a better idea. So it's sort of like with fluids. You know, we talked about how we're gonna study first fluids that aren't moving. You know, you have a cup of water, or you have some sort of fluid in a beaker or whatever. I don't know. You have an IV drip. We're going to study them in a simplified, controlled environment. And then we're going to try to study them in the next step up where they're moving, but they're moving in a nice manner, which we call, I shouldn't say that. So we have a flow that's not turbulent. We have this nice, smooth, laminar flow. And again, your argument can be, well, most fluids don't move that way. But the thing is if we want to be able to understand the real scenario, we have to start with these ideal scenarios where we can control things. And so I don't know that any of you are even thinking about that, but I know when I was a student, I would say, well, this seems, I hate to use the word stupid. My kid yells at me all the time about it. But, well, this is a silly law. And most of you are probably looking at it like, what a P1, V1, what is all this subscripts? It's like a nightmare to most people because it looks like letters and numbers and weird positions. But again, you have a guy like Robert Boyle who's in his mind, he's going to figure out how gases behave. He's going to be able to explain how they work. And so the first thing he's going to do is simplify things to control them. So he's only studying 2 things. He doesn't want to study 3 things or 4 things or 5 things or 1,000 things. He wants to control everything but 2 quantities. And he wants to see how these 2 quantities behave. And then once you learn how these 2 quantities behave, then you can hopefully have a better understanding and have a better way of explaining how things will behave in a real scenario. And sort of that's what you build up to. All right, so let's do a little textbook example, because why not? That's what we do. We do textbook examples. All right, so here's sort of what we call a book problem. So so maybe we have an oxygen tank or something. And it's being used in the following. So I have a tank or whatever. I just have oxygen. I'm giving it. I'm using it in some manner. Maybe you can imagine an oxygen tank. So let's assume that it's being used or at a rate of 5 liters per minute. I guess I should cross my T's. So losing my pen. So a question we might ask is, how long will it last? Now we're going to have to make some assumptions. I mean, we didn't tell you how much oxygen we're starting with. We're just saying that it goes at so many liters per minute. All right, so let's make some assumptions. In order to solve this problem, we have to know how much oxygen we're starting with, et cetera, et cetera. So here's our assumptions. So the first thing we're going to assume is that we're in a cylinder. It's like did I have a stroke this morning? I don't know. It's funny, not to go off topic, but it's interesting how, like, I teach, you guys, we have this class Monday and Wednesday, and then, so essentially I go 3 or 4 days without using this pad, and it's like the learning curve of writing on here. It's like you forget it. So anyhow, we're in a cylinder of, let's say the radius is 5 centimeters. And height, I won't spell it out because I didn't spell out radius. And we'll say that it's 30 centimeters tall. So again, we're using our famous friend from geometry, cylinders. We've used cylinders a lot, but as you know, cylinders show up in real life too, as in an oxygen tank. Okay. So we have a cylinder and we have oxygen in it. And as you're probably aware, that there has to be a pressure on this as well. Let's say pressure, how about we say 3,000 PSI. So we didn't say what PSI is. It's something you've probably used before, at least if you put air in your tires, but that's pounds per square inch. Remember what pressure is. Pressure is force over size. And so if you think about what PSI means, the unit, that's pounds per square inch. Does anybody have a question about this setup so far? Is there anything that's confusing that doesn't make sense? I don't know. Going once, going twice. I feel like I'm not going to get into that. Anytime you ask a question, you're supposed to give the audience at least 10 seconds to ponder. Okay, so anything? Okay, I just assume you're all legends and experts. What would you guys do if I just got up and left? How long would you wait before you decided to leave? If you're even there. Oh, there's Andrew's keyboard again. I like it. This is very good. I can see the Windows button. This is good. Maybe he'll give me a tour of his keyboard.
Was it 5 minutes?
I don't know. What's the rule? What's the rule? There's always a rule in that if the instructor doesn't show up, everybody's allowed to leave. Was it 10 minutes, 15 minutes, 5 minutes? I don't know.
Undergrad's quicker than
Yeah,
graduate.
that's exactly. It's funny you say that because they tell me there's a role, and then someone also once told me depending on the rank of the professor, that's how long they'll last. I said, well, that's rude, uh, you know. But then again, it's also rude for me to waste your time or someone else to waste your time, right?
Yeah, we have a
Your
pretty
time
low.
is important too. What's that?
We have a pretty low threshold. There's an exam tomorrow. Super low threshold.
I understand. Uh, yeah. That should be something that's communicated like on the syllabus. Like if I don't show up in the first 5 minutes, you can leave. Right? Shouldn't that be communicated? I think so. It's only fair. Your time is valuable as well. All right. So, okay, back to what we're trying to answer. We have an oxygen tank. And again, this is whatever. Fun problems. Just like you don't really care how fast fluid's moving in a needle. We're going to ask, well, I guess this is actually a little more possibly a real situation. How long will 5 liters last? Or excuse me, how long will oxygen last if it's being used at 5 liters per minute? And of course, you can't answer this problem, or at least answer the question, I should say, unless you make some assumptions like how much oxygen are we starting with? What kind of pressure is it at? And so these are the assumptions that we're going to make. So can we answer the question with just these two assumptions? Can, if we know the pressure and we know the initial volume. So let's think about what we can actually, we can get from this. So the first thing that I would say under what we're given is what's the volume? So we'll call it the initial volume. So we'll denote it V sub 1. And what is it? Well, we have a cylinder. So we've talked about cylinders before. The volume is the area times the height. Hello, we have a new, is this Marie? Hello, how are you?
Hi, good morning.
How are
I'm
you?
good. How are you, Dr. Grady?
I'm well. Thank you for joining us. Now maybe they'll be more lively for your for you being here.
Yeah, you can continue doing what you're doing. I just wanted to make sure I logged on and was here, so
That's great.
go ahead.
Thank you for joining us.
Yeah.
All right. So we're going to finish this problem real quick. So we have this initial volume, and what is this? It's pi what? R squared times the height. So that's the volume. That we've used this now a few times. The area, cross-sectional area, which is a circle, pi r squared, and then the height. And so if you go back to our assumptions, we gave a radius, 5 centimeters, and a height. So if we plug those numbers in, you have pi times 5 squared times 30. And of course, this is going to be centimeters cubed because we gave you units in centimeters. All right, so if we have this as our initial volume, what does that tell us? So a good way to think about problem solving, and I think this works not just for like taking tests or passing classes, but I think it's a good sort of a good strategy when you're solving any problem in life. And maybe I think of it differently now. I have 2 young kids and they're into like puzzles and stuff now. And so I think about how do I problem solve? Well, if it's a textbook type problem, I mean, what you want to do is you take everything you're given, and it's just like when you're doing a puzzle, I'm going to lay all the pieces out. I'm going to put all the edges here. I'm going to put all the center pieces here. And you sort of survey the situation. What can I gain? Now, I might not use everything, but if I tell you that I start off with a specific tank that has, or a volume, I guess I should say volume, a specific size of a cylinder with a radius and a height. Well, naturally to me, if that's what I'm given, the first thing, even if I don't need it, which in this particular problem I will, but I say, okay, what is the first thing, the most natural instinctive thing I can do, and that's determine the volume. And then also, if you're using context clues, we're talking about Boyle's law, which is volume. So, like, you know, a lot of times students will say, well, why did you do that? Well, I'm thinking, I don't know, I'm just doing things that seem natural. Why not compute the volume if someone gives me the radius and the height of a cylinder? The first natural thing to me would be, okay, I'm going to compute the volume. And then if you're using context clues, we're working with pressure and volume. Okay, so anyhow, you go to a calculator, you figure this number out, and then what do you do with this number? Well, we were also given a pressure. Oh, hold on. Hold on. We have work at home. Because it's early. Go back to bed. Okay, can you go upstairs though, please? Yes, that's fine. Thank you. Sorry about that. Welcome to quarantine. You know, this would happen. It always happens. Anyhow, I knew it would happen. On today, when we have special guests, the kids are away like zombies. Perfect timing. Okay,
I think it's great. So don't
you know,
worry.
yeah, you know, it's so well. That's the least. Usually, it's much more chaotic. I knew this was happening because I can hear the roof about to cave in upstairs. Anyhow, well, actually, you know, it's 10 o'clock. So why don't Marie? Marie, is that I can call you Marie? I don't. Is that what we go by?
Yes, of course.
Okay.
Yes.
Yes. So why don't you take over if you'd like to? Are you?
Yes.
So I spoke with Maddie, right? But she's not going to join us.
No, Maddie's actually on vacation.
Okay, cool.
She's our campus and community liaison. So she's the one that sets up the events and you know, sends out information to students or anyone in our database. So
Okay.
I just wanted to briefly introduce myself, thank everyone for joining today. Just want to let you know about career opportunities within Allegheny Health Network and what we have to offer to the CRNA. So can you just tell me what level students do we have?
So these are graduate level students.
Okay, so they'll be done in the fall?
I believe they will be done next year, right? Correct me if I'm wrong, but I think you guys are next year, correct?
Yeah, 2021.
Yeah.
Okay.
Oh, Jay, there he is.
Okay, so to be quite honest with you, it's not too early to apply.
Yeah.
If you know where you want to be, and I know all of you have been to Allegheny Health Network campuses, rotations through one of Allegheny Health Network facilities.
And we.
Okay, here I am. Did I lose you?
I lost somebody, but I think. Oh, you're back.
Yeah.
I'm back. Okay. So it's not. I was saying it's not too early to start applying. If you really know where you want to work, and I think you've all had some exposure to Allegheny Health Network with your clinicals. Correct me if I'm wrong, but we have full-time openings. Usually new grads aren't interested in casual, but I do have a casual position at West Penn. I make offers and people have start dates like a year out. So keep in mind that we could do that if it's something you're interested in. The majority of my openings right now are at Allegheny General Hospital. That's our flagship hospital, Level 1 Trauma Center. Full-time. I have openings at Forbes, West Penn, AGH. I I do have one opening at the Bethel Park Surgery Center, if anyone is interested in that. Jefferson Hospital, I do have one full, if anyone's in the South Hills. You know, that is always a option there. And Jefferson Hospital was not part of the Allegheny Health Network in the past. They had a separate company that that hired the CRNAs, but in December, January, we took those over. So we had an acquisition with them, and all of their CRNAs now are part of Allegheny Health Network. So depending on what hospital you work at is what determines your rate of pay. So we have different levels, level 1, 2, and 3. So depending on what hospital, that would determine your rate. And I can say those rates probably are not going to be the same as they are today when you graduate, because they've just been increasing, and we'll go through another increase, I believe, in September. So those rates will change. In addition to your rate, we have full-time benefits. So your benefits would go into effect the first of the month following a hire date. So realistically, say you started in August 2021, your benefits would go into effect September 1. Full-time health, excuse me, health, vision, dental, prescription drug plan. And then we also have, and this group, the CRNAs are the only group that have a special benefit plan. So in addition to your health benefits, you will get 4 weeks of vacation, 3 personal days, 8 sick days, 6 holidays. You get $2,000 annually to continue your education, an additional 5 days paid to attend conferences or continuing education. So it's a pretty robust benefit package. And like I said, the CRNAs are the only ones that are divided that way with personal time, sick days, holidays, and vacation. Everyone else within the health system accrues paid time off. We have a great retirement program, 401k retirement program, which you're vested immediately, and there's up to a 4% match. So Allegheny Health Network will match up to 4% you put in. So if you put in 3%, they'll match 3%. If you put in 5%, they're going to match 4%. Okay, you're vested immediately with the match. And then every year, Allegheny Health Network puts 1% of your annual salary into the retirement program, and that you're vested at 3 years, that portion of your retirement that Allegheny Health Network puts in. So, you know, it's a great benefit package. We also have, you know, ways that you could save tax-wise on like bus passes or childcare options, things like that. So, you know, those options are available to you as well. In addition to your salary, we call it it's a 905 payment. What it is every pay period you get money put into your paycheck that offsets your parking expense and your certification membership fees. So that is also paid for by Allegheny Health Network. Just so you know that. Does anyone have questions on the benefit portion of it?
Yeah, you said the 401k is vested immediately. That's 100% investment, or like 50% investment for the first year, 100 after that?
That 4%, whenever you start putting money into your retirement, and Allegheny Health Network matches that 4%, you're vested immediately with that
Okay.
4%. Now the 1% that they put in annually, you're vested after 3 years.
Okay, and that's 0% investment for that until the 3-year mark?
Correct.
Right.
Correct. Yeah. Anyone else have questions on the benefits? No? Okay. Has anyone, does anyone, I should ask, know where they want to work upon completing your program? Not yet, too early?
Actually, you know what? I apologize. I should have made it look like this.
Yeah,
I apologize.
that's okay.
I'm in instructor mode too much. I apologize
No, that's
about that.
okay. Don't worry about it. So where have you done your, like, majority of them, Dr. O'Grady, is at AGH, or are they all split up?
No, that's a good question. I don't know. It's unfortunate that we're on Zoom and
Yeah,
I don't get to ask the same questions and have the conversations. They would be better of answering
Okay.
than
Okay.
I would.
we were all split up, but we were only at one site so far because we got taken out of clinical in March after COVID started.
Oh, okay.
So we
Now,
really haven't had a chance to like see other sites.
when do you anticipate going back? Because I know they're starting to open
Yeah,
that up a little.
Not sure. It's kind of like up in the air.
Okay. All right. Do you think that's going to delay your graduation at all, or no? They'll just shorten maybe the.
We're not sure yet. Hopefully if it's anytime soon, it shouldn't, but they're
Okay.
not. We just haven't got a straight answer yet when we're going back.
Okay. So when you're at the hospitals, you know, and you have a feel for the environment and you think it might be a place that you see yourself working, do yourself a favor, make sure you meet with the chief, CRNA at each location, make sure they know who you are, express an interest. If you really think it's something you want to pursue at that location, you know, we'll schedule the interview. Offers are made, like I said, sometimes a year in advance. So it's not too early if you really are set on where you want to work. If you want to schedule a shadow experience, you know, maybe you don't have an opportunity to work at one of the facilities and you're thinking, well, that might be someplace that I may like to work, or I haven't had an opportunity to be there and I'd like to see it. You know, reach out to me or reach out to the chief at that site, assistant chief, and let them know. And we could arrange for that. So, you know, don't hesitate. I'll give you my email and my phone number. You can call me at any time, and we can arrange for something. Okay. Any other questions that I could answer for you? Like I said, I wanted to make sure you, you know, that I met you, you know who I am. Very open. You could reach me at any time if you know, I know you're busy during the week with classes. If you need to talk on the weekend or something, feel free to call me. That is never a problem, or in the evening. Okay. Any questions on employment opportunities?
Not yet.
No? Okay, well, I'm available. You know what I'll do is I will, Dr. O'Grady, do you want me to email you my email address
Yeah,
and
that'd
my
be
phone
great. So I
number?
think I have your contact from Maddie, but if you want to send me any information I can pass along, I'd be happy to do it.
Yes, I'll do that. I'll definitely do that. Maybe I'll also list the chiefs at each facility, their names. So
That would be great. Sure.
you know who to ask for. Okay, I'll do that. And in the meantime, you know, if you have any questions that you don't think of now, but think of later, just, you know, give me a call or shoot me an email. That's not a problem. And I wish you all the best of luck. You know, I hope things start to open up soon and you get back at the hospitals. And we appreciate what you do.
Thanks.
Okay.
Thank you.
Thank you
All
very
right,
much.
guys. Thanks. Have a
Thank you
great
for coming.
day.
You do the same.
Yeah.
Thank you very
Yeah,
much.
thank you. Thank you. Bye-bye.
Take care. And Marie's gone. All right. Look, now we get pictures. Two of you. Well, no, Caitlin has her nice, her portrait there. See, you guys aren't as creative as the peasant undergrads. They have all kinds of things like Tiger King pictures and all kinds of wild stuff. to show their enjoyment of the Zoom fun. Anyhow, so that was Marie. I just met her too. Oh my God, you should hear my upstairs. It's like a bomb's going off right now. My kid must have no hearing because all I hear is, and you don't hear, I don't know how you don't hear that. All right, anyhow, so let's finish this problem and then we'll call it a day, if that's all right with you guys. Of course it's all right. You guys are like, yes. Now go get a job. Is that where you guys want to work? I don't know. Allegheny Health Network, is that the place to be, or do you want to be at what's the place to be? Like UPMC, Allegheny Health Network? Who do you want to work for? I don't know. I have no idea in the healthcare world. They match 4%. That's not bad. That's pretty good. Most people don't match anymore. There you go. The Roche just canceled our match. I should yell at them for that. The Roni is ruining our canceling our matches. Our 7% match is gone because of the Roni. All right, I shouldn't joke about these things. That was poor taste. Anyhow, back to calculating how long an oxygen tank will last. Okay, wash your hands. Okay, good. All right. The things that you got to do. All right. Okay, so anyhow, I don't want to sort of, man, I really hate doing this on Zoom because it'd be much more enthralling if we were in a classroom together. At least my stupid antics might be better. Anyhow, so we have an oxygen tank. We told you what pressure it starts with. We told you its size. We calculated its volume based on its radius and its height. And what we're curious is how long will it last? And so what we want to do is we want to answer that. Now we're missing a sort of important piece of the puzzle. If we want to answer this question, we need to know what will the pressure be at the point in the future. So in order to answer the question, if we go back to the problem, we told you the initial pressure, but what we didn't do is we didn't tell you yet what would be the pressure, when the oxygen is completely gone, for example. So if we want to fully sort of solve this problem, or we need to have all the details. And so once we have this initial volume, so let's sort of state it this way. So we have what we call an initial pressure and volume. But what we don't have is we don't, for example, have a final pressure or a final volume. So in order to fully answer this question, we have to have one in order to determine the other. So let's assume, let's not say what, but so let's assume that it's released at a certain pressure. I don't know, how about 30? What do we do at the initial? It was 3,000, I think. So let's say it's 30 PSI. So what can we conclude at this point? Well, so by Boyle's law, if we have, let's say, our P1 V1 and P sub 2 V sub 2 or P2 V2, this is what the final pressure. So we'll use the 1 subscript to be the initial and the 2 to be the final. So our initial was what, 3,000, and we had an initial volume which we calculated using the volume of a cylinder. So it was 25 times 30 times pi. So if you just go to a calculator, I lost my screen, but what happened? So being that what happened to the whiteboard? Oh no. There it is. So if you go to a calculator and compute the volume, we can round it up to say, I don't know what, 2356. I guess, let's see, 0.2. And that has to be equal to our final pressure we said is 30, and then we want to know what the final volume is. So the only thing we weren't given yet is the volume. So we controlled everything other than the volume. So we want to know what happens to the volume. So solving this equation, will give us the volume when it's released. So before we calculate this, and maybe this problem got separated by our guest and stuff. So is there any questions on how the problem's formulated or what we're being asked to do? I mean, I know it's silly, but this is a standard type of textbook problem. So, you know, if you think it's curious or you have a question, please ask. I'm pretty confident. I think the textbook gives almost an identical problem, if I'm not mistaken. So, read it. All right. So if you do the algebra here, you have, or the algebra, if you do the arithmetic, and you take this number and you divide it by 30, as long as I didn't make any errors, you get something like, let's see, my calculator says 706858.3. And what are our units? Well, our units were what? We were using centimeters, correct? So if we're using centimeters, this is centimeters cubed. And you should verify that. You know, I've said this since the very first day of class, units are a great way to figure out how to solve these problems. If you think about it, the pressure or the PSIs will cancel. And the only thing that would remain would be the units on the volume, which is centimeters cubed. Does anybody have any questions about this? All right.
Nope.
Yeah, there we go. See, that's all it is. It's just a nope. All right, so here's what we know. We know how much space the oxygen takes up when we have a lower pressure. All right, so the only thing that you need to do is do a very simple sort of conversion. So if you remember, our initial question was, how long will this last if it's being given at a specific rate? And I believe, what did we say? Was it 5? I have to go back now. Yeah, so 5 liters per minute. All right, so how do you figure this out? Well, you look at the final volume, and you multiply it by sort of what, I guess we can call it a flow rate. The only subtlety is we told you how much the units were slightly different. We said liters per what? Liters per minute, I believe. So if we want everything to cancel out, we have to do it the following way. So what do we have? We have, you know, what, 706858. So that's in centimeters cubed. So I guess one way we can do this is we can put it in the liters. So that's actually not that terrible because we're already in centimeters cubed. Right? So how do you convert this into liters? Well, the easiest way in 2020 is to go to Google and put it into the Google machine, but you can also do it by hand. So we have, you know, what is that? 700,000 roughly cubic centimeters. All right, so anyhow, if you convert this to liters, or you go the other way and convert the flow rate to centimeters cubed. So we have what? 1158.3 if we convert, approximately. This is liters. And then what are we multiplying it by? Well, we're multiplying it by what is the flow rate? Well, we're going to get every minute we lose 5 liters. So one way to think about that is you can put 1 minute here and you can divide it by 5 liters. And so this is approximately what? Well, if you take this number and you divide it in your calculator. So if we didn't make any errors in our arithmetic, we get that it'll last approximately 2,316 minutes. Again, provided we didn't make any arithmetic errors. Does anybody have a question? Did anybody find an error?
It's just kind of a weird example to think about.
Oh, it is. It's textbook. It's like, I mean, again, look, when you do these problems and you think they're weird, I agree. But it goes back to the silly thing I've said numerous times now. Like, again, I'm assuming you guys have all given a shot before, used a needle. You don't really think about things like how fast is the fluid moving in the needle, right? It's silly, right? But that's the kind of stuff that you're, you know, part of like the physics idea of it is that you can do it if you wanted to, right? So, right, I mean, look, one of the issues that we have as instructors is we're trying to convince you that because we're nerds and we like this fun stuff, that you should care about it, right? And because society, for whatever reason, has said, if you want to do certain things, you have to learn these things. You know, I don't have a good answer for that. It's definitely a weird example, right? But it's a textbook example. People write books. People want you to learn these things. Do they make sense? Maybe, maybe not, right? But it's what it is. So it's kind of like we're jumping through hoops. Pardon me, I have to have a lot of water. But you could say that about most of the stuff, you know, that we're doing here, right? I mean, look, I said this earlier. Part of my job is a funny job because I'm trying to convince you guys to like things that you probably don't like, nor should we expect you to want to like or care about, right? You know, think about this. I mean, when I teach calculus, most people who take calculus will never use it in their everyday life, yet they're required to learn it. And so there's going to be people who go on to be engineers or whatever, and they're asked at some point to do these problems that are just textbook problems, and they're silly. They're, you know, no working engineer or a physicist or scientist will still do that unless they do it for fun, but we're still teaching. It's just what it is. So anyhow, does anybody have a question? All right, well, listen, let's end here. We'll pick up Wednesday. Like I said, I will try to update your grades, hopefully by the end of the day. Does anybody have any questions or concerns? And don't forget to reach out to Marie if you want a job, if you want to work for them. I don't know. Is it hard to get jobs for you guys? I would assume no, but I don't know. It probably comes down to how much you want paid. But anyhow, yeah, I mean, we probably could have went through this example a better way. Maybe I formulated it weird. As I said, I'd have to look at the book, but I'm almost positive that there's an identical example in the book. So maybe they do it a little better. That's not so sort of strange.
Yeah, well, it's the same example. It's just a weird.
I mean, that's what I'm saying. I mean, most of these things are weird because think about your perspective too. I mean, you guys are coming from actually already working, right? You guys have been working, I would assume, right? Most of you, at least, I think. And, you know, think about this. Like, say you're giving anesthesia to a patient. I was laughing when my second kid was born. My wife had to have a C-section because the baby was breached. And I'm in there. It was St. Patrick's Day. I'm Irish, right? So my kid's born on the 18th. Amy goes into labor on the 17th. I'm in there and I'm chopping it up with all the doctors and I'm trying to have fun. And I'm asking them these dumb questions like, how fast is the gas moving? You know, they're laughing at me like, what's wrong with this dude, right? Because, you know, the chief of the anesthesiology, they're not in there thinking all that crap, right? But, you know, at some point they had to do these examples, right? They had to pass a test where they calculated pressure and volume. And, you know, you're not going to be in an operating room or doing any of your real work thinking about it in that way. But you can if you want to, is what we're saying. So anyhow, listen, I don't want to hold you guys up anymore. You know, if you have questions, I'm going to post an assignment. We're going to talk more about gases. And again, I encourage you to reach out to me if you have any questions. All right. So, all right, listen, we'll end there. You guys have yourselves a great day. Thank you for joining, and I will talk to you Wednesday. Take care and be safe. All right,
Thank you.
guys. Thank you.